getting that data for us. So it's going through a proxy, so we're going to an off-domain location to grab that information. And essentially, that's bits of code missing out of there for me to try and fit on the screen, but essentially you can see near the bottom we have an eval statement, and that's where we're passing that externally grabbed data into. So that'll execute that for us. So if you don't validate that before you use it, like we aren't here, then you open yourselves up to an attack. So the next vulnerability is cross-site request forgery. And I didn't get a chance to come into the talk previously, but I guess anyone who was in the cross-site request forgery attack already knows how bad this is and how bad it can get. So really, what I'm talking about here is, again, it's not new, but it has the potential to be worse. And really, what you're doing with the cross-site request forgery attackers is, instead of executing malicious code on the client side, like we have in cross-site scripting, you're making a request, forcing a request to be made on behalf of that user without them knowing about it. So kind of just to reiterate that, it's important to remember that cross-site scripting is not cross-site request forgery. They are two separate attacks. So we've got a real simple example here, just in case anyone didn't make the last talk or not quite sure what cross-site request forgery is. We have a website here called ninjarental.com. So you come along, you put your username and password in, you hit submit. The request is sent to the server. The server authenticates you and sends a session ID back. So when that user is using the Ninja rental site and he wants to rent a Ninja, he wants to just rent the regular Ninja for £100. He doesn't want to hire Chuck Norris. I probably wouldn't either. He's probably a little bit volatile for my liking. But the guy chooses the regular Ninja for £100, hits submit. It sends that request to the server. The browser sees that, oh yeah, I've already got a session value for that, so he doesn't have to re-authenticate. The browser just sends that value along with the request. His account is debited in the back end, and then he gets a Ninja. What if, whilst he's still authenticated to that site, I get him to come along to my dodgysite.com, and whilst we might be laughing at Agent Smith there to start off with, I think ultimately he's going to have the last laugh here, because whilst you might think we can't make this request from this other site, we can use some tags like an image source tag or an iframe source or a script source tag to bypass a protection mechanism called the same origin policy, which should have prevented this attack happening. But by design, those three tags allow that attack to happen. So when the user comes on this site, the funny pictures of Agent Smith load up, but in the background, the browser sees that it's got to make this request to ninjarental.com as well. And you can see basically what it's doing is it's making a request to hire that Chuck Norris Ninja. So he's now going to have £1,000 debited from his account without him ever actually sending that request. And again, the browser, being helpful, just sees that request being made in the background, sees you've got a session value for it, and sends that along, and the request is made. So some people look at those examples and say, well, that's probably a bit too simple to work in the real world. We're going to take a look at an example in a minute where an attack almost the same as that was being exploited against Gmail for about 18 months, I think, before it was fixed. So what can make this worse in Web 2.0? Well, we can do attacks using XML and JSON. I'm going to look at a JSON-based cross-site request forgery attack in a minute. They can be a little bit tricky to do, but they're certainly possible. And one of the biggest issues with Web 2.0 is that cross-domain access is essential. You know, when we look at things like mashup sites, they are essentially a cross-site scripting attack in the way that they're built, and they have to allow that cross-domain access. I think, talking about the mashups, I think Douglas Crockford once said that they are kind of built as a cross-site scripting attack because everything is cross-domain requests. And then really, like I mentioned before, same origin policy isn't going to protect you. Whether we're still relying on same origin policy or not, we're going to see less and less protection from that going forward. So things like the XML HTTP request and even JSON data should only be called from the same domain. But again, we're going to look at in a second how you can get around that as well. So firstly, a very simple real-world example of a cross-site request forgery attack against Gmail that essentially brute forced a password reset against your account. So again, it was using the image source and the iframe source tags. So again, we're starting to see similarities to the example earlier. So what the researcher found was that he could make these requests directly to reset the password with Google. So it has to provide an old password, so your current password, and then the password he wants to reset your account to. Now, normally when you do the password reset with Gmail, you have to enter a CAPTCHA. But by making this request directly, he could bypass the CAPTCHA system. So he could brute force those values and try and reset your password for you. As I said, I think it took around 18 months, I think, from this guy first reporting it to when it actually got fixed. And then the next kind of JSON-based attack I'm going to look at is also against Google. I'm not trying to beat up on Google here. Just like later on, I'm not going to try and beat up on Facebook. But they've got the best examples of these attacks so far, in my opinion. So normally, as I said, the XML HTTP request should only be able to pull in data from the same domain location. And the same for JSON. We shouldn't be able to request data from an off-domain location. But that's not very Web 2.0 friendly. We mentioned before that we have to allow that cross-domain access. So we have a thing called JSON callbacks. And what a JSON callback allows you to do is to wrap the JSON data within a JavaScript function. So you can make that cross-domain request or grab that data, the JSON data, from a separate domain. So what a researcher found out was that he could use this to his advantage and steal your Google contacts. Now, fortunately, he only used it as a proof of concept, so he didn't really steal your contacts, but obviously other people could do. So really, at the top of the screen now, we have the JavaScript function called Google, and we're waiting for the JSON data to be wrapped in there, essentially. When he receives it, he's just going to do a document.write, write out your contact information to the page there. So at the bottom, we can see that there's also a URL to Google Docs. So normally what this URL would allow you to do is, when you're using Google Documents, you should be able to view your contacts whilst you're doing it. But the researcher found out if he put the callback parameter on the end of the URL, wrap that within a JavaScript function, whenever you come to his page, that code would execute, grab your contacts, and then, well, in this case, he just write it to the page, but he could have sent that anywhere he wanted. So SQL injection, again, not a new vulnerability. It's been around for a long time. And what we're seeing now is probably a different way of exploiting SQL injection, or a different motive for the attack in particular. So again, it's not new, but it's potentially worse. And really, what a SQL injection attack is, it allows an attacker to inject his own bit of SQL into your backend SQL query. So we have a really simple example here where we're going to take in a username from the user, and we'll do a select star from users where the name equals the username that the guy has provided. So if he provides, a 1 or 1 equals 1, the example that probably everyone's familiar with, then that query will become, give me all the usernames where it's 1 or 1 equals 1. So give me all the names where it's equal to true. And again, this is a real simple example, but we're going to look at a real-world exploit in a minute, which wasn't too much more complicated than this. So again, that was a simple example, but SQL injection's been used to steal large amounts of data, generally cause chaos on the internet through different means. So card systems, they lost 40 million credit card numbers through a SQL injection attack. We've seen automated SQL injection attacks compromise tens of thousands of machines by exploiting vulnerabilities on the desktop. We're going to look at one of these attacks it's only about a week and a half old in a minute as well. And when I try and give people a measurement of how many of these vulnerabilities we're seeing every year, I tend to use the amount of CVE numbers issued, and every different vendor will give you a different statistic on how many SQL injection attacks occur every year and so on. But for me, I find the CVE numbers quite useful. What's also useful is there is a great interface. So if you just do a Google search for CVE statistics, there's a great way to search for these yourself. But really the point is that of the CVE numbers issued in 2008,